So, hello everyone, I'm Shubham Maddhashiya, fourth year undergraduate student at IIT Kharagpur. Today I'll be talking about IVIVC.jl package under Pumas. You all have already heard about Pumas, so let's get started. So what is IVIVC? IVIVC, a predictive mathematical model which describes the relationship between the in vitro property of dosage form and in vivo response of the same dosage form. And in vitro property means drug dissolution profile, and in vivo response can be plasma concentration profile. So basically what we are trying to do is that when a drug is administered into body, there are two simultaneous processes going in the body. One is absorption of that drug and another is elimination of that drug from the blood. These two processes makes concentration of drug in the blood. First it increases up to maximum value and then it start decreases. So this is a plasma concentration profile in the blood, and we want to somehow predict using IVIVC from the result based on the experiment in the lab. And the experiment is done in artificial environment which can mimic the bio conditions. So IVIVC can act as a surrogate for bioavailability, optimization of formulation to support biowaivers, and thus it minimizes human trials and cost and time in drug development, and it can also help in scale up and post-approval change process. So IVIVC is simple. It's involve 5 major steps. The first one is in vitro modeling, which gives you F dissolution profile. Second one is in vivo deconvolution, which gives you absorption profile. And then we establish IVIVC in between these two profiles, and then we apply convolution and IVIVC model to get our predicted plasma concentration profile. Then we validate our IVIVC model and see if this is up to mark or not. If this is up to mark, then we get our IVIVC model. If not, then we go back to our Vitro modeling and we change our Vitro modeling function and set up parameters and do all this over step again. Now I'll talk about all these steps one by one. So first one is in vitro modeling. In IVIVC.jl package, currently there are 4 vitro modeling function. Those are standard. First one is Emax, second one is vbool, and third one is double vbool, and fourth is McGod-Banneker. So first we have to use read vitro function to read in vitro data. Then we select the batch, and then using the vitro model function and passing the symbol to the vitro modeling function, we can model the vitro data. And there is also plot recipe to plot the vitro model comfortably. And we know we can fit more than one model to our vitro data. So to help you to choose the best one, there are some functions available in IVIVC.jl, AISHIB, AICC, and Bayesian Pharmaceutical area and R-square. And you have to just pass your vitro-based data object to this function, and we'll get the result. If you don't want to fit all the model one by one and see which is the best, you can try all vitro model function, which will try all the available model in the package and select the best one on the basis of metric you will provide. So after the first step, second one is convolution. As I have already told you, there are 2 processes. One is absorption and second one is elimination. These two make up the plasma concentration profile in the blood, and to get this absorption profile from plasma concentration profile is known as deconvolution. There are 3 methods available currently: Wagner-Nelson method, Ludick-Hellman, and differential equation based method. After getting the absorption profile, it's time to establish IVIVC model. So there are 4 currently available model in the package. First one is direct one-to-one relationship. Second one involves amplitude scaling and time scaling factor. And third one add one more time shifting factor. And fourth one involve one more parameter of amplitude shifting parameter. So after we get our estimated IVIVC model, we put our IVIVC model in governing differential equation of elimination and absorption process and integrate over the time course to get the predicted plasma concentration profile. So at final stage, if we validate our model, there are two kind of validation we can use. One is internal validation, in which we use the data from the formulation that is used to build the model, and one is external, using the data that model has never seen. And in the validation, we see some PK parameters like Cmax and area under curve, and calculate the percentage error in the predicted and observed. So you can do all these major steps one by one using the helper function from IVIVC.jl package. But this is you can do all these steps only one function call, and that is do IVIVC. You just have to provide the your Vitro view and reference view data and some keywords argument appropriately. So that's all. I'm happy to take questions.
We have 2 minutes. Is there any questions?
Cool.
Okay, sorry. Maybe in the interest of time, we should just move on, okay?
Cool.
Sorry.
Thank you.
So can we set up the next speaker?